Okay, this will be our first geometry test of the year. It's on Geometry Chapter 1 review. It's basically the same things we went over in class if you were there today. First is a finish the sequence problem. It is you're going to make a conjecture based on a sequence with finding the last term that I asked you to find. The problem we went over today was 2, -4, 8, -16, 32, and then we found the last to be -64. We had multiplied every one times -2. So times -2 times -2. So when we got to 32, it was 32 times -2, and that's how we got to that answer. Another example of a conjecture problem would be find the next term in the sequence. If I was to go 1, 3, 9, 27, and then what would be the next conjecture we would make in that sequence? First we need to decide how we got from 1 to 3. We said 1 times 3, 3 times 9, 9 times 3, 27 times 3, and we would arrive at 81. So basically it's looking for a pattern, which is something that mathematicians do, is look for a pattern. So look for a pattern to find that next sequence. You're going to have 5 of those. I think you won't have a problem with that. The matching vocab basically is anything that's been highlighted in Chapter 1. We went over these today. I'll kind of zoom in just to make sure if you need to pause your video to see. But this is going to be matching. And it's 25 of these. You should get all of these. Don't miss any. That will help you out tremendously on your test, getting those points that you need. All right, so there are those. Now, Section 3, we're going to deal with a sketch similar to page 13 and 14. Okay, on 13 and 14, what I'm talking about, I'm going to turn in my book real quick, which is the teacher's edition. And I'll try to clear it up and zoom it in, so if you're trying to study, it gives you some the answers to look at. For instance, this shape right here, we're talking about 2 planes, one suspended above the other, with a line that is passing through both, and then there's some lines that are coplanar lines on the top plane. So we're looking for things like points A, B, and C are collinear. That's false. A, B, and C are not collinear. A, B, and C are coplanar, however. So look at 3 through 8 on that page. That should help you be able to see some of the kind of diagrams we'll have. Also down towards the bottom, here's another one. I have 2 intersecting lines. This is another true-false. Decide whether it's true or false. For instance, point A lies on line L. Point A does not lie on line L. Point A lies on line M. So we did these for homework, but just to make sure you got all the correct answers, those are what those look like on page 13. And then on page 14, I'm going to go up just a little bit to the top. We're dealing with these 2 type of shapes. Now these are a little bit harder sometimes for students to see. Because they are 3-dimensional. Remember that the line that is broken, or the dotted line that is in the back, is there because it's supposed to be behind the shape. So it's 3-dimensional. Both of those shapes have 6 different planes, 4 sides, a top, and a bottom. So make sure that you understand what the difference in coplanar, collinear are. Also, as far as just picking out lines that are points that are coplanar and points that are collinear. It's the biggest thing on that. All right, but that does the two shapes or what I said, the 2 sketches on Section 3. Okay, so now let me get back. Let's look down on Section 4 deals with problems, and you're going to have 10 problems. These are problems we went over in class. This is a segment addition postulate problem. If xy is 12, what is the measure of xz? I will work this one over so that you can see, because many students are wondering what is actually going to be given on that problem. So what happens on this is, I'm going to come in here, make sure you can see it. We're going to have X as a point right there. We're going to have Y as a point right there, and Z right there. Okay, and so on this, zoom in so you can see it, this is our line segment. Okay, I'm not drawing a real straight line right now. It's no problem. All right, there's our line segment. And what is given is 2x plus 2 here, 3x minus 1 here. Those are our two given segments that we have. And so this is Y, this is Z, and this is X. And then in the instructions it says if XY is 12, what is the measure of, get where you can see it, what is the measure of line segment XZ? So that's what we're looking for. When we get done, we want to know what XZ equals. And I think you need to really pay close attention to detail on this, because just when you solve for X, that's not what we're looking for. We're looking for the length of this entire segment. Now, in geometry, if we give you something, then you need to use it. Obviously, 2x plus 2, we have to use 3x minus 1. Well, we can't add those together because we don't know what it equals. The only thing that we've been given is that xy is 12. So from here to here is a measurement of 12. All right, so what we're going to do then, we need to solve for x. We can do that with just that information. We're going to say 2x plus 2 equals 12, because they told us that the length of the segment is 12. Now we're going to solve for x. So what I'm going to do is I'm just going to simply go minus 2 to move over the 2, which gives me 2x equals 10, and then I'm going to divide both sides by 2 and end with x equal to 5. So 5 is the value of x. Now I need to know how far it is from y to z. That way I can find out the whole length. So what I'm going to do, where this segment is 3x minus 1, I'm going to substitute in for the x of 5, because that's what I know x is equal to. Now it's just simple order of operations. 15 minus 1 is 14. So now from here to here is 14. So if that portion of the line segment is 12 and that portion of the line segment is 14, I just add those together and xy is equal to 26. And that is our segment addition postulate. In order to get that segment addition postulate. All right. Now, same thing on the back here. We have find the value of x. Now all we have to do is find the value of x. We don't have to actually plug it back in for anything. So when I'm finding the value of that, first of all, I need to recognize what I'm looking at. I'm looking at an angle. Right off the bat, I'm given that this angle is right. So I like to color mine in. That just lets me know that's a right angle. So that means that this angle right here, this angle here, and this angle here added together equal 90 degrees. So they're complements of each other. All right, now this line means that it is equal to this. So they're telling me this is 4x plus 5, this is 8x. Well, since this angle equals this angle, then I also know this is 4x plus 5. Now, I can set my problem up by saying 4x plus 5 plus 8x plus 4x plus 5 equals 90. Then I just combine like terms and I get 16x plus 10. Move the 10 over, subtract it over. 16x equals 80. Divide by 16, x equals 5. And that is our angle addition postulate that we use for that. Not too hard. Now we have find the distance between 2 points. I think everybody's had this for several years. The distance formula is right there. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. Points are 3, negative 2 and 4, 1. And my distance on that is 3.2. 3.2. All right, a few more problems, almost done. I do sheet. All right, now another type of problem that we're faced with is a midpoint problem. We've worked a distance problem, now we must work a midpoint problem. So we're going to find the midpoint, or basically this one is find the endpoint given one endpoint and the midpoint. All right, so we're given an endpoint at -5, 9, midpoint at -8, -2. Formula is m equals x1 plus x2 over 2, comma, y1 plus y2 over 2. And what we do there is I actually split them apart. My x's are here, my y's are here. Those are my x and y coordinates from my midpoint. And then this is from my actual endpoint. So I'm looking for this x and this y gives me the other endpoint. I'm going to multiply both sides by 2. -16 equals x minus 5. Add 5 over, and x is equal to -11. So one point of my other endpoint is -11. And then on this, I'm going to multiply both sides by 2. And I'm left with -4 equals y plus 9. Subtract 9 from both sides, and -13 is y. So the other endpoint is -11, -13. The only difficult problem to that one is that it did not give you two endpoints. It gave you a midpoint endpoint. If it had given you two endpoints, you would have just plugged them both in here, added them, divided by 2, and it would have gave you your midpoint. So it's a lot easier when you're looking for the midpoint. And our last problem that we're looking at is 1/2 y plus 27 is an angle. Y plus 12 is an angle. 7x minus 20 and 5x minus 88. All right, these angles that are formed by these intersecting lines are, this is a linear pair. These are linear pairs. Linear pairs are supplementary angles, which means they add up to be 180 degrees. So I'm going to start with my x's. I just say 7x minus 20 plus 5x minus 88. Combine like terms, add 108 to both sides, divide by 12, and I obtain my answer to be x equals 24. Do the same for my y's. Combine like terms. After I add 1/2 y plus 27 plus y plus 12, I get 1 1/2 y, or 1.5 y plus 39 equals 180. Subtract 39 both sides and get 1/2 y, or 1 1/2 y, excuse me, equals 141. I'm going to divide both sides by 1.5, and I end up with y to equal 94. Y to equal 94. Now, as for possible bonus, we're probably going to have something, find the area of the shaded region. So, in this, I might put a square. Let's get a square right here. Let's say the side, and then bring that on up into a rectangle. Okay, so you can see this. So I have a square and rectangle. I'm going to say my rectangle's length is 12. I'm going to say my square side is 6. And I'm going to give you, well, I can do it this way. Let's do it this way. Let's give you this side as 6. And let's tell you that this length is 3. And then I come in here, as a lot of times on the ACT, and shade all this in. And I ask you to find the area of the shaded region. Well, first what we need to do is find the area of, let's find the area of the square. One side of the square is 6. So that means that all four sides are 6. So this is 6, that's 6, this is 6, and that's 6. So my area of my square is A equals side squared, or A equals 6 squared. So my area equals 36. All right, now I'm going to find the area of my rectangle. But you say, wait a minute. All we have are our lengths. We have one length is 12 and that length is 12. What about the width? All we know is this part is 3. And that's true until you get right here, and then you know it's 6. So you have 3 plus 6, and that gives you 9. So your lengths are 9. I mean, your lengths are 12, and your width is 9. And so the area of a rectangle is A equals LW, or A in this situation would equal 12 times 9. A equals 108. So now I have the area for the rectangle, the area for the square. So what I need to do is find the difference. Take out the square. So I'm just going to take that area of 108 minus the area of the square, 36, and 8 minus 6 is 2. And then I'm going to go 10 minus 3, so 72. So that lets me know then the area of the shaded region is 72, and that would be in square measurements. I didn't put a measurement there, but it would be. But 72 is the area of the shaded region. That's your test, just chapter 1. Make sure you can also visit your Khan Academy app or go to khanacademy.com. Look at the first 3 videos of Khan Academy app, 1, 2, and 3 on angles, and you should do fine. Good luck, and I hope you do well on your first test.